In this video lecture, I'd like to talk about what are known as z-scores. A z-score is equal to x minus mu over sigma. Now each of these terms are defined here below. X is a value on some variable x. Mu is the population mean. And sigma is the population standard deviation. And the z-score, once it's solved for, it indicates the number of standard deviation units a score is away from the mean. Let's go ahead and take a look at a few examples to illustrate a z-score. Our first example, we'll have x equals 44, mu equals 40, and sigma equals 4. Now in this example, we're going to go ahead and plug these values into our z-score formula. So z, and you should be able to do this along with me now. What is our x? We have an x of 44, a mu of 40, using this formula up here, and a sigma, or population standard deviation, of 4. So that's z equals 4 over 4, or z equals 1. Let's take a look at two more examples. In our next example, we'll consider an x of 36, mu once again of 40, and a standard deviation for the population of 4. Once again, using our z-score formula, we see that z is equal to 36 minus 40 over 4, which is negative 4 over 4, for a z of negative 1. Okay, in our last example, let's consider an x of 40, a mu of 40, once again, and the same standard deviation of 4. Okay, in this example, we have z equals 40 minus 40 over 4, which is equal to a z of 0 over 4, or a z of 0. So in these three examples, we had the same mean and standard deviation, a population mean of 40, and a standard deviation of 4. Notice that across the three examples. Now when we had an x of 44, we got a z of 1. This is a positive value, a z of 1. When we had an x of 36, we got a z of negative 1. And an x of 40, we got a z of 0. So you can see from this example that we can have positive z-scores, that we can have negative z-scores, and that we can have a z-score of 0 as well. Now I said earlier that a z-score indicates the number of standard deviation units a score is away from the mean. So let's go ahead and take a look at that with these examples and see if we can illustrate this concept. When I have a score of 44, notice how this score of 44 is above the mean, right, of 40. By how many points is it above the mean? It's above the mean by 4 points. And we can see that right here in the numerator. This tells us how far above or below a score is from the mean. This is a deviation score. If you watch the variance and standard deviation video, you'll recall that x minus mu is a deviation score. How far an x deviates or departs from the mean. So here we see that x was 4 points above the mean. The standard deviation here happens to be 4. So notice that x was above the mean by 4 points, which is the same amount as the standard deviation. So you could say that this score of 44 is 1 standard deviation above the mean. That's exactly what our z-score tells us. Notice how we got a z of 1. It's telling us that a score of 44 is 1 standard deviation above the mean. Now here the standard deviation is 4 points. So what it's really saying is this score of 44 is 4 points above the mean. Here we see a score of 36, which happens to be 4 points below the mean. And this gave us a z-score of -1. So this is telling us that a score of 36 is 1 standard deviation below the mean. And then finally, with our score of 40, notice what it is in relationship to the mean. It's exactly equal to the mean. So here, we see that a score of 40, does it deviate at all from the mean? That's what you want to ask yourself. It does not, right? It's equal to the mean. So that gives us a z-score of 0, which means it's 0 standard deviations away from the mean. And if it's 0 standard deviations away from the mean, that means it's just equal to the mean.